So in this video we discuss the second type of problems in the test of significance of proportions. So we apply the first formula of Z, that is x bar minus np by square root of npq. So this formula when we apply means when a coin is tossed or a die is thrown. And the second formula we apply when the standard deviation is and mean is given. So we discussed these problems in the previous video. Now we solve the problems on the first formula, that is when a coin is tossed or a die is thrown. So this is the first problem. A coin was tossed 400 times and the head turned up 216 times. Test the hypothesis that coin is unbiased at 5% level of significance. So unbiased means impartial. So without any partiality, if you toss a coin, one coin is tossed how many times? 400 times. And the actual heads, how many heads we got here? 260 times. So what is the hypothesis, what is the assumption we are taking here is, the coin is, if the coin is unbiased, at 5% level of significance. We have to test this hypothesis at the 5% level of significance. So what is the hypothesis they given here? The coin is impartial. This is the hypothesis. The coin is impartial. So either we have to accept this hypothesis or we have to reject this hypothesis depending on the Z value. Now first, probability of success. If toss a coin, always probability of getting head, there is a chance of getting is 1/2, and there is a chance of getting tail, that is always p plus q is 1, therefore q is equals to 1 minus 1/2. Now what is the expected number of success? Expected number of success we find by n into p. N is number of times the n is 400. 400 times the coin is tossed, that is 400 into 1/2. 1/2 is the probability of getting head, that is this is the expected number of success. 1/2 into 400 is 200. And but in the given problem, what is the head turn up? 216 times, that is the observed value of success. What this is the value they given in the problem. This is the expected number of success what we calculated depending on the probability of a success, that is 200. This 216 is the observed value of the success that is given in the problem. This is your x bar. Now the formula is Z is equals to x bar minus np by square root of npq. Now the numerator term, we find the value here only, that is x bar 216 minus np means expected number of success, that is np 200. 216 minus 16 is 200 is 16. So we find it here separately, the numerator term x bar minus np. Substitute here and square root of, what is the number of n is 400 into 1/2 into q is 1/2. So 2 ones are 2 ones are, this is 100. Square root of 100 is 10. 16 by 10, that is 1.6. Now we have to verify at which level of significance, that is 5% level of significance. So for the 5% we have to consider 1.96. For the 1% we consider 2.58. So in the problem itself they ask at which percent of significance we have to test the hypothesis. Here they ask the 5%, therefore what the value 1.6 is less than 1.96. Modulus of Z is less than 1.96, therefore we accept the hypothesis depending on the Z value. If it is less than 1.96, we accept the hypothesis that the coin is tossed impartially. So at the 5% level of significance, you have to write the conclusion, then only you get the full marks here. Then conclusion that the coin is unbiased. Means we are accepting the hypothesis that whatever whenever the coin is tossed, it should be tossed in impartial way. Therefore, we conclude that the coin is unbiased at the 5% level of significance. So this is the method to solve when a coin is tossed. So first find the value of Z, that is expected number of success and observed value of success. Observed value of success is always x bar. Whatever the value they give in the problem, always you consider that as x bar. And the expected number of success we find by using n into p. N is the number of trials and p is the probability of success, that is your np. Find x bar minus np and substitute, find the value of Z. And you see that either they are the 5% level or 1% level of significance. If they are not asked any level of significance, either you consider 1% or 5% by default. So if they clearly mention it is a 5% level of significance, in that case you have to verify the value of Z with 1.96. If it is less than, we accept the hypothesis. If you got the Z value greater than 1.96, we reject the hypothesis. Here we are accepting the hypothesis that the coin is unbiased. So the next problem is, so a die is thrown or tossed, actually a die is thrown 960 times and 5 appears 184 times. Test the hypothesis that the die is unbiased. Means there is a partiality is there. Biased means partiality. Unbiased means impartial. Okay. Again we have to apply the first formula here. So coin case alli matte again die case alli, because one coin and one die we are tossing. We apply the first formula here. Now first we have to find the probability of success P. So the probability of success is 1 by 6. Means if you toss if you throw a die, there is a sample spaces, there is a probability of getting 1, 3, 4, 5, 6. You can get any number if you throw a die. Means how many, the number of possible cases is 1, 2, 3, 6. So denominator always you have to write the number of possible cases, and numerator is number of favorable cases. The number of favorable cases means 1. So what is a favorable case here? If a die is tossed 960 times, 5 appear. Only one time we get the 5, that is 1 by 6. Probability of success P value is 1 by 6 and Q is 1 minus P, that is 5 by 6. 5 by 6. First find the value of P and value of Q and expected number of success. So 1 by 6, what is the probability of n into P? 1 by 6 into how many times the die is thrown? 960. 1 by 6 into 960, that is 160. And what is observed, whatever the value they give in the problem, that is your observed number of success, that is this is your x bar. In the problem what they given, that is your x bar, and what we are finding, that is n into P, 960 into probability of success is 160. Now difference x bar minus np, either you can substitute directly here also, otherwise we find the numerator term separately. X bar minus np, x bar means observed number of success 184 minus expected. So what we are expecting when a die is thrown to getting the possibility of getting 5, that is 184 minus 160, that is 24. Substitute here and square root of n into p into q, substitute the values, you get 2.0978. Now here they are not mentioned at which percent of level of significance we have to test. So by default we consider 5% level of significance here. Whatever the value we got here, 2.07, that is greater than 1.96. Therefore we reject the hypothesis. We reject the hypothesis that the coin is biased, the die is biased. So is the die is biased means, so the value is greater than 1.96. Therefore, the die is, the hypothesis what they said, biased. So the value is greater than 1.96. We reject the hypothesis that